So students, the simple relation between, not in terms of vector, but simple relationship we write between the magnitude of the linear velocity. So this is the magnitude of the linear velocity of the particle which is moving in a circle is related to its angular velocity, that is omega, and this r is the radius of the circle. So we can write it like this. Now what about the particles which are there on the axis? So you know that the particle which are there on the x-axis, along the z-axis, which is the axis of rotation. So for them this r is equals to 0. So if r is equals to 0, so obviously this v will also be 0. So they are stationary. So the particles, so underline this line in your book, which is there. Particles on the axis of rotation are stationary, and this verifies that the axis is fixed. Now Harsh Swami, you can read.
Yes, sir. Note that we use the same angular velocity omega for all the particles. We therefore refer to the omega as the angular velocity of the whole body.
Okay, thank
We
you.
have correct.
Okay. See, this is what we have, means written, that the angular velocity. So here, like angular speed, I have written. So magnitude of angular velocity will be same for all of them, like this divided by time taken t. Okay. So this, because they are traveling the same angle. Okay. So that is why the angular velocity omega for all the particles are same. Okay. So that is why we write this omega, because it is same for all the particles of the body. So we say it angular velocity of the whole body. Okay. So this omega is the angular velocity of the whole body. But as the different particles are at different distance from the z-axis, axis of rotation, so this will be different. So this is same for the whole body, for all the particles. This omega is same, but r is different. So that is why this linear velocity is different, because they are traveling the different distance. So from this formula, mathematically also you can say, because the r is different, so but omega is constant, so v is directly proportional to r, we can say. Okay. So larger is the radius, more is the linear velocity. Okay, got it? Okay, Harsh, you can continue reading.
We have characterized pure translation of a body by all parts of the body having the same velocity at any instant of time. Similarly,
Sorry,
we
this
may
line.
characterize pure rotational.
What is pure translation? So pure translation motion means all the parts of the body having the same velocity at any instant of time. So if you remember, we started our chapter and there was figure of the translation motion, that is figure 7.1. So page 142, figure 7.1, you can see that the translational motion of a block down an inclined plane. So two particles are shown, P1 and P2, but even the rest of the particles, all the particles of the body, they are traveling with the same velocity, okay, at a particular instant of time. So at a particular instant of time, this is what we need to remember. Okay, yes, Harsh, continue.
Similarly, we may characterize pure rotation by all parts of the body having the same angular velocity at any instant of time.
Yes,
Note that
good. So there in pure translation motion, they have the same velocity. Okay, so of course that was linear velocity, so same linear velocity. So similarly in pure rotational motion, we have same angular velocity. Okay, so at any
note
particular instant of time. Yes. Yes.
Note that this characterization of the rotation of a rigid body about a fixed axis is just another way of saying, as in section 7.1, that each particle of the body moves in a circle, which lies in a plane perpendicular to the axis and has a center on the axis. In
Yes.
our
So,
discussion,
okay, thank you. So, you can see figure 7.4 we did. So, figure 7.4 and 7.16 is the same figure. Okay, the only thing is that there were two particles, and here we have only one particle. And second thing is that here we have written the angular displacement delta theta, and we have drawn the linear velocity direction also. So that is the difference. But this figure 7.16 is same as figure 7.4. Okay, now
Yes.
your screen is not visible.
okay, my screen is not visible. Okay, now it's visible.
Yes, sir. Now
Yes,
it's
sir.
visible.
Okay,
Yes, sir.
Yes, sir.
so this is what I have written, that the simple relation v is equals to omega r, and omega is same for all the particles of the body. So that is the angular uh, velocity, magnitude of angular velocity of the body. And but the r, that is the radius, that is the distance of the particle from the axis of rotation, will be different. So omega is same, but r is different, and that is why the particles will have different linear velocity. So you can see that they have to travel different distances. That is why. Okay. So now, Vinay, you can read. Vinay Pundir. Vinay, can you hear me? Okay, Aditya, you can read. Anjali, you can read.
Yes, sir. In our discussion so far, the angular velocity appears to be a scalar. In fact, it is a vector. We shall not justify this act, but we shall accept it. For rotation about a fixed axis, the angular velocity vector lies along the axis of rotation and points out in the direction in which a right-handed screw would advance if the head of the screw is rotated with the body.
Very good.
The
Okay.
magnet.
Okay. Thank you. Underline this line. The angular velocity vector. So it's a vector. Where is the direction? So it lies along the axis of rotation and points out in the direction in which a right-handed screw would advance if the head of the screw is rotated with the body. So you can again do it with the right hand thumb rule, like that we use for the cross product also. So in physics now, this right hand is very important. So curl your fingers in the direction of, so you can see figure 7.7a. Okay, so figure 7.7a are also, there are two figures. So the figures on the left hand side, which direction it is moving, clockwise or anti-clockwise?
First one clockwise and second one anti-clockwise.
Yes, Mansi?
So first one is clockwise, no?
Yes, it is clockwise. Yes, absolutely. So hold your fingers clockwise. So hold your fingers clockwise along with this figure. So clockwise means 12 to 3 o'clock, like that. So you can see that your thumb is pointing in which direction? right side. Yes, it is pointing on the right hand side. So it is pointing on the right hand side. Now what about the figure second? Yes,
Anti-clockwise.
anti-clockwise. Very good. Now means keep your fingers anti-clockwise, so you have now the thumb will shift to it will towards the left hand side, isn't it? So initially the thumb was in the first figure the thumb is on the right hand side. So hold your finger, you can hold your fingers in clockwise direction, thumb will be on the right hand side, and if you hold your fingers on in the anti-clockwise, the thumb will be on the left hand side. So have you understood what the direction of angular velocity? And what is the magnitude? Magnitude angular magnitude of angular velocity is omega is equals to d theta by dt. So at any particular time we can tell the magnitude of the angular velocity and its direction. Is this okay?
Yes, sir.
Okay. So who is going to give this demo? Is showing this along with the book, holding it. Yes, who wants to be volunteer? Come on, hurry up. Vinay, we can't hear your voice. There might be some problem with the mic. Yes, who wants to be volunteer? Come on, quick. See, we need to this chapter there will be cross product and this, so right hand thumb rule we need to right hand we need to use again and again. So who is comfortable showing it? Anjali, are you comfortable?
No, sir.
Okay. Veena, you just need to show your book and your right hand, how you are curling the fingers. Yes. Okay, good. Yes.
But I have to show, sir.
Okay, how you need to do? Bring your hand on the finger on the figure. Yes. Bring it on the figure. Yes, yes, yes. Now hold. Just this is a disc. So you need to hold this disc. Hold this disc. Yes, yes. Yes. Very good. Yes. That's correct. Yes. Absolutely. Very good. Yes. So this finger, the rotation is moving in this direction, and the direction of angular velocity is perpendicular to the plane of the rotation along the axis of rotation. So absolutely. So the difference between the directions of the linear velocity and angular velocity, you can see even in figure 7.7b that the direction of linear velocity is tangential, but the direction of angular velocity is actually perpendicular to this plane containing the circle. Can you see that difference? Yes, students.
Yes,
7.7b. See the direction of v. So right there, tangential. Okay. And for omega, it is perpendicular to the plane of the circle along the axis. Is this clear? Parallel to the axis. So students, at particular point, now you can show me for. So students, have you understood this concept?
Yes,
show
sir.
for second
Yes, sir.
figure also, which is there on the right hand side. Yes. How will you? Yes. Very good. Yes. Absolutely. Thank you so much. So that's the now. So the direction of angular velocity is perpendicular to the plane of the circle. So you can see that in figure 7.7. So what about the direction of angular velocity is perpendicular. So at point P, is this clear, students? The angular velocity vector omega is directed along the fixed axis as shown, and the linear velocity of the particle at P is v is equals to omega cross r. So now you have to put your fingers on the omega and move them in the direction of r. So your thumb will tell you the direction of the velocity. So that's cross product. So cross product, you need to put your fingers on the omega, okay? The direction of the omega, your finger should point in the direction of omega. Can you do it? Just try to do it and curl them towards r, okay? So omega to r. So how this we are going to show? So this is your figure and this is your point P, right? And where is your omega? So this linear velocity is equals to omega cross r. So this is just like a cross b we have done, okay? And what is the direction of a cross b? So that is the perpendicular to the plane containing a cross b, okay? So where is omega? Omega is along the z-axis, which is perpendicular to the plane of this circle. That is your omega. Where is your r? R is the position vector, means here. So from C center to P, that is r. So where is r? So both the one thing you need to remember, students, here, that the direction of r is this, okay? That's the direction of vector r. So this is omega. So you need to extend this, okay? So that's r. Distance is r. Now you have to move your fingers from omega to r. So move your fingers. Can you move them from omega to r? So hold your hand. Means your fingers will be in the vertical direction, and your thumb will be pointing, means inside the screen or inside the plane of the paper. Your thumb will be showing it inside the plane of the paper. Okay. So hold omega and rotate it towards r. So this is very important that you need to do. Veena, can you show it to us?
This thing I'm not able to understand how to hold my finger.
Okay, Mansi, you would like to try?
Okay, sir, let me try once.
Yes, you can try, yes. Okay. No. See, point your fingers along omega first. Yes, show me your fingers. Yes, along omega. Yes. No. Vertical. Like thumb is pointing vertically downwards, not upward. Rotate it 100. Yes. See, now the fingers are pointing along the. Keep these fingers in parallel to horizontal, parallel to the plane of the book. Parallel to the plane of the book, these fingers, yes. So that is the direction of omega, right? Your fingers is the direction of the omega. And now curl them towards the r. Yes. That is r, yes. So we are finding the cross product this time. What we are finding? Cross product. So in cross product, what we need to do? Omega cross r, a cross b. So move your fingers, put your fingers along a and move them towards b. So omega, yes. So where is the thumb pointing? So thumb is pointing in the direction which is perpendicular to the plane containing omega and r. Where is it pointing? It is pointing downwards. So if the circle, if you are moving in this, so the direction of the speed will be actually tangential. Okay, now as per the figure, now this is one of the scenario. Now as per the figure, this is now as per the figure, now tell us the direction of the angular velocity as per the figure. So now your fingers will point upward, right? So in the figure now, actually, yes, finger upward and thumb going into the plane of the paper. Can you do it? Thumb going into the plane of the paper.
So like this.
Yes. So the one that you were showing, yes. So that's actually and what about this plane now? This figure which is shown. So omega to r. So point. Yes. So now you have to keep your fingers upward. Now upward, vertical direction, pointing upward. No, pointing upward along z-axis. Yes. Thumb will be no, fingers are pointing upward vertically upward. Yes, vertically upward. And your thumb, yes, vertically upward. Yes. See, whole hand along, yes, vertically upward. And so that is the direction of angular velocity, vertically upward, and then you are moving it on the right hand side. Right hand side is your direction of, so, and then inside the plane of paper means inside the plane of the paper will go, so the direction of. So I hope you people have understood it. So it's better if you take to understand this, it's better if you take 3 pens as 3 axes. Okay, you can have in one hand, can you hold 3 pens? Can you hold 3 pens? Can you hold 3 pens like 3 axes? Pen or pencil? And you have to so you need a volunteer along with you to show, because in the one hand you will be holding the 3 pens, and if you have means the laptop, then you can show it with the camera, otherwise so what's the direction here? Yes. So those who have the laptop, they can show. Who wants to show this? This is very important. Okay, there is this very important discussion. There is no need of there is no logic of moving ahead unless and until we do it by hand, and it's so simple. Yes.
Sir, may you please show?
Okay, you want me to show? Okay. So let me see if my. Can you see me? Can you see me?
No, sir.
Okay, so
No, sir.
I have to stop the presentation means. Can you see me now? Yes.
No, sir.
No, sir.
No, sir.
Presenting. My camera is on, but you are not able to see me.
No, sir.
Okay. My camera automatically turns off when I show. Can you see me?
No, sir.
No. No, sir.
Doesn't matter any of Mansi, you can try it. So simple. Just keep your three pen or pencil, as three axis. There's some problem with my camera.
Okay, sir. Let me try once.
Yes, you can try it. So simple. Yes. Yes, very good. Yes, very good. Now, yes. So obviously, see, your angular velocity is in upward direction, and your omega is in upward direction. This Reynolds pen that you are holding, its cap is at the top. This blue pen. So that's the direction of the angular velocity, right? And this black pen, you can take it as x-axis. Okay. So just keep your fingers vertical. Keep your fingers in vertical direction and move them towards. Yes, okay. Yes. See, your thumb will point along one of the axes, like x or y, whatever you are taking as horizontal axis. Your thumb will point along one of them. Yes. So hold your pen with one hand. Hold all the three pens with one hand. Yes, okay. Now your thumb will point along one of the pens. Along one of the pens your thumb should be. And fingers are upward. Fingers are vertically upward. See, you are supposed to hold it in the left hand, these three pens. You can hold it in the left hand. It's better. And yes. Now instead of, okay, so see, you are starting from omega. Omega is vertically upward. Your fingers are supposed to be vertically upward. Okay. See, it's little bit see, your fingers are supposed to be vertically upwards, and your thumb is along one of the axes, which are horizontal ones. That's the way. See, this horizontal pen, instead of it pointing towards me, point it away from me. This horizontal pen, now point it away from me. No, this one is okay. Yes, this one, yes, this one away from me. Opposite, 180 degree, rotate it, 180 degree rotation. Yes. So 180 again means hold them again. This pen is supposed to be on that side. Okay, that's also fine. I want this pen actually. Okay, students, I will see to it if you people can simply, I am telling you, hold your fingers along the z-axis and move them towards y-axis. Can you do it? Hold your fingers along the z-axis and move them towards y-axis. So your thumb will point along the x-axis. Okay. So this is what this. So the whole means now the physics will be like this. So we are supposed to be very much comfortable with it. Students, you can try it out. Okay. We'll continue from this point tomorrow, and I will see if there is some video. So I will post the video also regarding this. Okay, revise it. We'll meet.
Okay.
Okay.
Okay, sir.
Okay.
Yes, sir.
So